all of you. Today in this class we will discuss about another distributed energy resource, that is the wind energy system. If you could see that nowadays the power demand is increasing exponentially, and to meet such power demand, so we have to construct either new corridors or new power structures. So, in that case, if we talk about the transmission structures, it demands more cost, and also it demands areas, and some other issues are also there. If you see we have coal based generations, so there the carbon dioxide emission is also one issue. So, to meet the power demand, we have many other alternatives. So, one alternative energy source is the wind energy system, which is the largest renewable energy source to provide the power to our demand structures, to our customers. Coming to this part, in all India power sector, the installed capacity is more or less greater than 325 gigawatt. And if you could see here, the coal is about 195 gigawatt, gas is 25.3 gigawatt, oil, and we have thermal, hydro, nuclear, and RES means the renewable energy sources. If you could see this particular figure, here the coal is around 62% and this renewable source 18%. So, our target is to basically to increase the power generation from renewable energy sources, not from the coal generation based system. By 2030, the target is to have 40% total energy should be from renewable sources, and in fact, this is the capacity 62053 megawatt or 62 gigawatt of grid connected renewable power installed capacity we have by 31st November 2017, and wind power, out of it the wind power is 32,746 megawatt. And another part, this is a very important point here I just want to mention. So, our target by 2022 is to have 175 gigawatt of energy from renewable sources, and that is to 100 gigawatt from the solar power and 70 almost it is written here 60 to 70 gigawatt from wind power generation. And this figure is not impossible, it is quite possible. If you see this energy map of the India, the solar map. So, these red colors basically show the sites where the wind potential is present. If we will try to harness the wind energy on these particular sites, so it is possible to have 300 gigawatt. So, it is quite possible to meet the 60 gigawatt by 2022. This is from the website. We have Ministry of New Renewable Energy, that is a wing of our Government of India ministry, and this wing is basically dedicated for renewable energy sources. And here some of the figures I have collected by 28th to 2017, February 28th 2017. And you see the first one is the grid interactive power, capacity is in megawatt, and the second one, the B part, is off grid capacity power, and capacity is also in megawatt, and some of other renewable energy sources also. These figures are provided from the renewable Ministry of Renewable Energy system sites. And if you could see, the wind is the largest power generation. As far as India is concerned, the wind is the major power renewable power source, and second is the solar, and third is the small hydro power plants. And if you will see the off grid or capacity power, captive power, here this waste to energy urban industrial we have 165.45, and also we have biomass 16651.91, and biomass rural industrial we have 18.34, and so on. The point here in this particular part we want to discuss that in India the wind plays a major role as far as the renewable energy sources are concerned. And if you could see this pie chart, the India stands as a 4th position globally. This China first 42.8% share, and the second one is US 15%, Germany third 10%, and India 6.6% globally. The position is 4th largest wind generation country. And as far as India is concerned, we have the largest wind farm, which is located in Mupandal wind farm, and it is located in Tamil Nadu state, and the capacity is 1500 megawatt. And other states like Rajasthan, Maharashtra, they are also following, and these are the figures which are noted down here. And overally, if you will see that wind is a very, the largest source of renewable energy sources for us. So, we have that potential that the forecasting figure which is given basically 300 gigawatt power we can harness from the wind system. So, that is quite possible if we will increase the technology and the controls or monitoring systems better. So, we can always do it by our smart grid technology. The question now comes that why wind energy is very important and why it is very advantageous for us. The first point is it is clean and zero emissions, which is required for us. If you will see the coal based generation, there we have carbon dioxide emission process is present, like the very dangerous gases like NOx, SO2, CO2. But these gases are not present where the wind energy system is present. That means, we have a quality air and quality water, and of course, if the poisonous gases are not present, so the climate change is also not difficult, it is in healthy condition. And second point is reduce fossil fuel dependence. So, if we will have more and more power generation from wind system, so of course, to meet the demand we have to basically reduce the dependency from the fuel cell like fossil fuel cell based generation, that is our coal based generation plants. And yes, of course, it is renewable in nature. The wind is basically from heating of the sun, the unequal heating of the earth's surface. So, it is renewable in nature, that is no end to the wind. So, these are few key points where we can see that wind system is more advantageous than the coal based generation system. And these are the potential impacts and issues. The first one is the property values, and the second one is noise and the visual impact, land use and wildlife impact. So, if you will just see overally what are the drawbacks, what are the disadvantages of the wind system. So, the first point is the property values. If you could see that while just planting, just siting this wind farms, it needs large lands. And second is that while this wind generator runs, so the sound will be produced, and that sound, that noise is also not desirable. That if with proper siting the wind farms we can reduce it, of course, or using proper technology, advanced technology we can reduce, but the noise is present. And the visual impact, yes, aesthetic look is essential. So, that is why the wind farm like the wind turbine blades or towers we have to take care, so that the visual look will be better. And land use and the wildlife impact. The wildlife is very important. If you are using this wind farm for our power purpose, using the power or harnessing the electricity, then we have to also careful towards the wild animals. Basically, the wind farms are located far away from the cities or localities where the wind is available. But however, we have to take care of the wild animals. That should not be any risky factor. That should not be a risky factor as far as the wild animals are concerned. Now, I will just discuss here what is this wind energy. If you could see here this figure, it is a schematic figure of this wind energy system, where I have shown these two arrows, basically the wind flow of the wind system, wind, and this is our blades, these are the blades, and we have shaft and gearbox and the generator. Now, in general in wind system, the kinetic energy which is present in wind is converted to the mechanical energy. with help of this mechanical system. Gearbox, we have shaft and we have this rotor. So, this rotor basically converts the kinetic energy which is present in the wind to the mechanical energy. And next stage, the mechanical energy is converted to electrical energy using this generator. So, we will discuss more about this principle of operation of the wind system, and also we will learn the different parts of the wind system. Now, if you see here the second picture, we have here the offshore wind farms. First of all, this we have onshore means on the land we have wind farms, also on the offshore on the top of our ocean on the level. So, we have also wind farms, two things. If you see on the land, the speed of the wind is basically not steady and also not so high, and in that is why we just put the height of the wind tower is very tall, if you could see in the on lands. So, to access the to harness the more wind, to get the more wind, so we have to make it very taller. But here in case of ocean, the flow of the wind is steady and also it is little bit faster also. These two things, faster and steady. So, due to this, many countries also they are planning offshore wind plants, and that is also helping, that is also coming in a very bigger form, and it will also, of course, it will mitigate our power requirement. Coming to the constructional feature of the wind system, the first one I will just talk about the rotor and the blades, and second system is the pitch. Third one we have the low speed shaft, then we have gearbox, then we have high speed shaft, and then we have generator, then we have controller, and of course, we have this braking system and yaw drive and yaw motors, and then the tower. Now, we will discuss one by one what are the functions of each component. Coming to the tower of the wind farm, the towers are mainly divided into two categories. The first one is the vertical tower and second one is the horizontal tower. If we come to this figure, this is our horizontal blade or horizontal tower of the wind system, and this is our vertical wind system. What is the difference between these two? The first difference is that in case of horizontal based type of wind system, here the generator and the gearbox are mounted on the top of the tower or top of your this system. This is our tower, but in this case the generator gearbox are mounted on the bottom. So, that is the basic difference, and the another point is the diameter of, if you will see the rotor blade, the rotor which rotates. So, the rotor blade, the diameter is measured in terms of horizontal, but here if you see the rotor diameter is measured in terms of vertical. So, that is how these two systems or these two structures are different from each other. And here some pictorial concessions I have just collected. If you could see, this is how the vertical blades or vertical structure rotates, and this is our horizontal structure. This is also vertical, this is also vertical. Coming to the blades of the wind farm. So, this structure A, this is A, this is our blade of the wind energy system. What is the function of this blade? This blade is a rotating component which is designed aerodynamically to work on the principle of lift and drag. This is important, drag, to convert the kinetic energy into the mechanical energy. This blade is responsible, if you will see this figure, these three blades. So, this particular blade is designed to convert the kinetic energy which is present in wind to the mechanical energy. Coming to the rotor part, this rotor is present here, the basically the B is a hub, this hub and the blade together, these two things are known as rotor, and this blades, it is written here, this blades and the hub together called as the rotor of the wind system. This particular rotor hub is connected to the blades, rotor blades, and to the rotor shaft, and it is also placed where the power of the turbine is controlled physically by pitching it. So, what is this pitching word? What is the meaning of it? It is a method. It is a method of controlling the speed of the wind turbine by varying the orientation of the pitch of the blades. If you vary the orientation of the wind blades, the wind turbine blades, then what will happen? We can access more wind power, or we can harness more wind kinetic energy, which will be converted to mechanical energy. That is known as pitching of the blades, and that mechanism is only possible using this rotor section of the wind system. Now, coming to the nacelle, this nacelle means it consists of the first one, it contains the gearbox. We will come to the function of gearbox, and next one is the low speed shaft, and the third one is the high speed shaft, generator, controller, and the brake. So, this all the elements together called as nacelles of the wind energy system. And here if you could see this particular picture, so this here the nacelle, and in this nacelle we have the generator, we have this controller, we have the gearbox, low speed shaft, and also high speed shaft. All are present inside this nacelle of the wind system. Now, coming to the low speed shaft is principal rotating element which transfers the torque from the rotor to the rest of the drive train. It transfers the torque from the rotor to the rest of the drive chain. If you will see here, this is our rotor and this is our blade, and if the wind comes and it hits to the rotor the blade, then the blades are rotating along with the rotor. So, then this particular low speed shaft will transfer this particular energy or kinetic energy, rotational speed to the next section of the wind energy system. That is what, and also it supports the weight of the rotor. This low speed shaft also supports the weight of the rotor, and third function is it is also connected to the gearbox to increase the RPM of the generator. This is very important. This low speed shaft is also connected to the generator, to the gearbox, to increase the RPM of the generator. That is also another function of this low speed shaft. And what about this gearbox? The gearbox steps up the speed according to the requirement of the electric generator. Inside the wind system we have electric generator. Basically we have DFIG nowadays, double fed induction generator, and also we are also in some cases also we use the PMSI, this permanent magnet synchronous generator, and in that case to step up the speed according to the requirement. What is our requirement, where we can get optimum electrical power or optimum torque of the machine. So, according to that we have to basically step up the speed. So, that is possible using this gearbox system inside this wind energy system. Now, this gearbox connects the low speed shaft to the high speed shaft. These two are, this low speed shaft and high speed shaft are basically connected with using the gearbox system, and to increase the rotational speed of the machine. Now, what is the function of this high speed shaft? This high speed shaft is basically the shaft of the generator. The generator which is mounted on the top of it, this tower, and inside this wind energy system, it generates, it basically converts the mechanical energy to the electrical energy. Now, the function of this high speed shaft is it transmits the speed and torque from the gearbox and drives the generator. That is the function of this high speed shaft. Now, what is the function of this brake? If you could see this figure, here is the brake. The braking system is always desirable in every system because it is a safety concern for the wind system. What is the function of this brake system? Basically, during the very stormy condition and extremely high wind flow, so we have to basically brake the system operation. So, in that case the braking system is the system which controls or which brakes the operation of the system. It stops the wind turbine for its safety. That is what the brake system does. Now, and types of brake, basically we use mechanical brake, or also sometimes we use aerodynamic brake system. Coming to the generator part, we will discuss more about this generator section in the subsequent slides, that it converts the mechanical energy to the electrical energy. That is what our requirement. From the wind energy system we need the electrical energy finally. And the controller, basically it if you see, the controllers are also desirable, it is not desirable, it is essential part of every renewable energy system. So, similarly in case of our wind system also we have controller. This controller basically measures and controls parameters like voltage, current, frequency and temperature inside this nacelle, and also it controls the wind direction, wind speed and shaft speed, because our wind direction, wind speed are directly or indirectly linked with our output electrical power. So, we have to control, if we are interested to control the voltage, current or frequency output of the generator. So, we have to also control the wind speed and also the shaft speed and also the wind direction. So, the direction where we could have maximum power generation. Now, this anemometer is also there, it is basically sensor which measures the wind speed. Here it is, it measures the wind speed, and it is further it is used for our controlling purpose only. It is a feedback, it will be feedback to the controller, and for wind resource assessment it is normally fixed on the top of the wind turbine. This anemometer is basically mounted on the top of the wind energy system tower, and to provide or input to the controller for power regulation and braking beyond the cut out and survival wind speed. Again, this anemometer is also very important equipment as far as the controlling of the wind system is concerned, because if you do not know the wind speed presently, so we cannot control the system operation. So, that particular measured wind speed will be sent to the controller presently what is the wind speed. If it is within the range, within the stable operation of the wind system, so it will just operate in steady manner. Otherwise, we have to cut, we have to stop the operation. And then this pitch is also important, pitch that already we have discussed, that these blades are turned or pitched out of the wind to control the rotor speed and keep the rotor from turning in winds that are too high or too low to produce electricity. Basically, the blades are designed in such a manner, pitched means it is a given certain direction. With respect to the direction of the wind, the axis of the wind, I mean this wind blades, it keeps some angle. So, if this is my wind direction and this is my blade direction, I mean the axis of the blade, so what is the angle they are just extending. So, that is how we have to keep in such a manner the pitch angle of the blade, so that it will just get highest energy from the kinetic energy from the wind system. The tower is also important. Here if we could see different type of towers we have demonstrated, like tubular steel tower, we have tubular concrete, lattice, three-legged and different types of tower, and for aesthetic look, good look, and we are planning also different other types of towers also in research, in construction. So, and remember this tower height is in some cases this steel tower, the height is almost about 80 meter, and the blade size is within 30 meter. So, and it is quite I mean if it is a land based wind energy system, the height we have to increase, because in the top layer the wind speed is higher than the bottom layer. That is why the wind speed, I mean the tower height is quite large. And this is our wind vane. Basically it is an equipment which is present inside the wind system. Here it is, if you will see this figure, this is our wind vane, and this wind vane measures the wind direction. It does not measure the wind speed, the wind speed is measured by this anemometer. The wind vane basically measures the wind direction, because we have to also control, we have to know the wind direction and communicate with the controller for orienting the turbine properly. And that if I know the wind direction properly, in what direction the wind is, I mean it is high, I mean the kinetic energy, because we have to harness more kinetic energy. So, in that case to orient the turbine in a proper manner, this wind system is essential. We have this ear motor, ear drive, ear motor. So, these two are installed in this tower of the wind system, and when it is required, so the wind turbine will be oriented accordingly to towards the wind direction, so that we can access more kinetic energy. And this is how this wind drive and ear motor operates. Now, this is a very typical wind farms picture. Here our wind turbines, and we have the generator. Basically, here it is this is a nacelle section where the generator is present, and from there we will take out the electrical power, and here these are the transformers, and which will step up the voltage to higher level, and further also we have this further stepping up the voltage, and this particular voltage or power will be sent to the nearest grid system. This is our grid system, and it is a grid tied wind farm system. Basically, these wind farms are located or connected near to the, it is not near to our grid system, it is far away from the grid system. Nowadays also we are planning HVDC link based wind farm system. Means if the power is generated by the wind system, we can send the power to the HVDC links to the nearby grid system. The HVDC system can transfer more power in comparison to the AC system. It is very far away from the grid, then we can take the help of HVDC. Otherwise, we can connect the wind generated power to the nearest grid using the AC lines. Now, I will come to the principle of operation of the wind system. There is a very simple picture I have kept. This A and B together called as the rotor of the wind system, and this is the flow of the wind. The first stage is the flow of the wind, and second stage inflow of wind activates the rotor and blades. This A stands for the rotor and this B is the blade. Now, when this wind, due to the wind flow, the rotor and blades together they will rotate. Now, after this we have this C here, we have the main shaft. Due to this rotor and blades movement and this main shaft, it is here, will rotate through the gearbox. This gearbox is the D section. We have main shaft, we have the gearbox. Now, together this our main shaft, and next is our generator, and this is our another high speed shaft. So, these two things will rotate together, and finally, the electrical energy output will be there. So, that means we have here the kinetic energy and we have here electrical energy output. This is the input power and this is the output power in case of the wind energy system. And these are some of the stages. These are the block diagrams. The first stage, the power energy conversion part is there as far as the wind turbine rotor is concerned. At the wind turbine rotor section, we will have the power energy conversion. What is that type of power energy conversion? The input will be the kinetic energy and the output will be mechanical energy. The first stage is basically conversion of kinetic energy to mechanical energy. And second stage we have again the gearbox. This gearbox will convert, basically it will just control the speed of the shaft, so that it will just maintain the RPM of the generator at the required value or required level, so that we can harness more power at the maximum torque speed of the generator or maximum point of the wind speed. So, that is what the aim of this gearbox. It will step up, it will increase the speed of this generator, and this conversion again is mechanical energy to mechanical energy at this stage. Now, coming to this section, the generator section, we have this mechanical energy is converted to electrical energy, and here is the output, the electrical output P out is here, it starts from here. Now, after this generator we have power electronic interface, because in case of AC circuits, like if we have like different systems of frequency, let us say wind system has some frequency and our grid has some certain frequency. So, if you could have like electronic interface, so easily we can match the frequency of the grid and with the frequency which is generated by the wind energy system, that quite possible using the electronic devices. And so, that is why we have this power energy conversion, and apart from this we can also like for transferring purpose, if it is a long distance, what we do, we first rectify the wind energy, like because the wind system generates AC voltage, AC power, and just like your solar system, it generates DC power, and here we will get AC voltage or AC power, and that particular AC voltage, AC power will be converted to DC using this conversion rectifier system. And next the DC will be converted to AC using the inverter section, and that is what this power electronic interface does. And after that the AC system or AC signal will be connected to the our power system through a proper stepping up the voltage, and of course, because we have to match the frequency and voltage of this particular grid system, that we have to synchronize the wind energy system with the nearest grid. And it is a German aerodynamist, he said, Albert Best, he said that maximum of 59.3% of the theoretical power can be extracted from the wind, not more than that. That means 59.3% of this kinetic energy can be converted to electrical power, P output. That is what the maximum energy we can expect from the wind kinetic energy. And losses up to 10% in the drivetrain and 10% in the generator. So, we have 20% loss overall. Now, how much left out? That is 30 to 35% available wind energy into the electrical energy system. And this turbine will convert this much of energy, see, because we have also losses, 35% of this wind energy is going to be converted to electrical energy. Now, we will discuss here about the different types of wind energy system, where we will talk about different types of machines, how they are used to convert the mechanical energy to the electrical energy or kinetic energy to mechanical energy, then it will be converted to electrical energy. The first one is fixed speed wind turbine generators, and in this case if you see this one, it is a large scale wind power and a grid system. Here it is the wind turbine. The wind turbine provides the mechanical input to the gearbox and it will go to the synchronous generator. And for controlling the speed of this synchronous generator, we have sensors which will sense the speed of this machine, and it will just send to the speed controller, and accordingly it will just control the pitch angle of the blade. And that is how this particular fixed speed wind turbine generators work, and finally you will get the AC output. Now, if you look this particular schematic diagram, here we do not have any electronic device or electronic interface. There is no rectifier, there is no inverters are used in this particular system. Directly the generator output is going to be connected to the grid system, and this is quite challenging, because you know this wind speed is varying in nature. If the wind speed is varying in nature, so it is very intermittent in nature. In that case, obviously we may not get the power at every time equal amount, or sometimes it may happen there is no wind, so there is no power generation. So, in that case the control of this particular system is very challenging using this sensors of the sensors which sense the speed of the machine. So, today we will stop here, and the next class we will talk about the different types of synchronous generators which are going to use to a DFI system, which is basically the main part of this wind energy system. And so, in this particular lecture we have discussed the very basic power scenario of India, and where this what are the different states we generate the wind energy system, and after that we have discussed the fundamental principle of operation of this wind system and its constructional features. And just now we have finished one part, that is the fixed speed wind turbine generator. Thank you so much.